Hello and welcome. Today we're going to be talking about central tendency, or how we identify the middle of a distribution of scores. So central tendency is just a fancy way to say the middle. But identifying the middle of a group of scores isn't quite as easy as you think it may be. We actually have three different ways in which we measure the middle, each of which are more appropriate for a different type of distribution or a different distribution shape, or even different types of data. And they're called mean, median, and mode. Let's start backwards and work our way forward through those. So the mode is the most frequently occurring score in a group of scores. We often use the mode to identify the most frequently occurring nominal variable. So if we think about gender identity, the modal gender identity in any particular research sample may be female. One example of the mode could be marital status among undergrad students. So this data you see here is from over 900 undergrad students who participated in a survey that we gave. And we can see that among a nominal level variable, you have different categories. People fall into different categories of marital status: single, married, engaged, divorced. And undergrad students are much less likely to be married than the general population. How do we determine the middle of a distribution like this? How would we represent the middle? Well, the middle is best represented by giving the modal response. And we see here that the modal response option is single. Could we compute a mean score for this data? I guess we could, because we represented each of these categories numerically, but a mean score wouldn't give us very much information. In fact, it would give us faulty information. The mode is also useful when you have a bimodal distribution, meaning that the shape of the underlying distribution kind of takes on two humps to it. So what we see here is the average time between eruptions for the Old Faithful geyser in Yellowstone National Park. You see we have two different peaks at which the geyser tends to erupt. We could take an average of these scores, but if we took an average of these scores, it would be somewhere in the middle. So you'd be sending someone to Yellowstone at the exact wrong time to see the eruption. What would be more helpful information for somebody in a context like this would be giving them the two different windows at which you're most likely to see an eruption. Okay, so that's for nominal or categorical variables. What about quantitative measures of the middle? How do we quantitatively identify the middle? Well, that's where we use the median and the mode. The median is the score that's exactly in the middle of a distribution of scores. So if we took every single score in a distribution, so if we wanted to get the age of a class, right? So if you had 400 people in a large lecture hall, we wanted to find the median age. We would take every age in that lecture hall and line them up from lowest to highest, and the median would be the one exactly in the middle. It's important to note that if there are two scores, right, if you have an even number of scores, then you won't have an exact middle. It would be between the two middle scores. Right? If you have an odd number of scores, it's easy to find the exact middle because you'll have an even amount on each side of the middle. But if you have an even number of scores, then it's an average of the two scores that are exactly in the middle. So if the two scores in the middle were a 20 and a 21, then the average of that would be 20 and a half. And we most often report the median when we have highly skewed data, meaning that the data tends to cluster on one side of the distribution or the other. You don't have a beautiful normal curve, and your data are not normally distributed. We'll talk in future lessons how that can be problematic if your data are not normally distributed. So here's an example with 5 different SAT scores. So let's say we took the mean of these SAT scores. The mean, the average of these SAT scores are 388. Does that best represent these scores? The mean is 388, whereas the median is 290. It seems like there may be one extreme score that is pulling the mean up. Representing central tendency with the mean, with the average of these scores, doesn't really tell you much about the totality of the scores. In fact, that mean sits between the one extreme score and the 4 that are lower. A better representation of these scores may be the one that represents more scores, which is in this case the median. It's more accurately reflective of the most scores in this distribution. The last indicator of central tendency that we'll talk about today is the mean, is the mathematical average. So to calculate the mean, you sum all scores in a distribution and you divide by the number of scores that you have. And we've been using that word distribution a lot. So a distribution is just a collection of scores on one particular variable. So if we had a large lecture class of 120 people, if we collected all of their ages, that the array of ages that we had would be considered a distribution of scores. And among that distribution, We could identify the mode, we can identify the median, and we can identify the mean. So when we talk about a distribution of scores, we're really just talking about a collection of scores. But back to mean. Mean is the mathematical average, and it's the best indicator of central tendency as long as your data isn't skewed in any way. It's the one we most often rely on when running statistics, and it's the most commonly reported measure of central tendency for when you have normally distributed data. When we have a perfect normal distribution, that's when our scores are normally distributed in the shape of a bell curve. We'll talk about that more in our video on dispersion. But when we have a perfect normal distribution, the mean, the median, and the mode are all equal. When we have skewed data, meaning that our data are either on one side of the distribution or the other, that kind of changes things a little bit for us. You'll see here that when the data are positively skewed, which means that we have more scores on the low side of the distribution, a little trick to remember how to identify skewness, it's where the tail points. It's the direction that the tail of the distribution points into. So if the tail of the distribution is pointing to the positive side of the distribution, we call it a positively skewed distribution because it's missing those positive values. If the tail of the distribution is pointing towards the negative side of the distribution, then we call that a negative distribution because it's pointing towards those negative values. But you'll see when we have a positively skewed distribution, the mean, the median, the mode are not all in the same place. So in a typical undergraduate classroom, we have scores ranging from 18 to 22. We might have some more extreme scores as non-traditional students return. This would represent a positively skewed distribution because there are fewer scores on the high end of things. But you'll see what happens is that the mean, median, and the mode are more spread out in skewed distributions such that the mean gets pulled more towards those extreme scores, whereas those extreme scores don't really affect the median as much and certainly don't affect the mode at all. So in a positively skewed distribution, the median may be the most accurate representation of central tendency. In a negatively skewed distribution, we have the exact opposite, where the modal score is the highest, followed by the median, followed by the mean. So let's say we were assessing how close people are to their mothers. Most people tend to have a close relationship to their mothers, so that is a variable that may be positively skewed. And you see that in this case, the mean score doesn't necessarily represent a lot of the data set. Doesn't give us the best information as to where the middle is, whereas the median provides a little bit more information, is a little bit more accurate on where the middle of that distribution of scores actually is. In our next video, we're going to be talking about dispersion, or how spread out those scores are around the middle. And these are two incredibly important determinants of the type of statistic that we're actually going to assess when we're modeling these relationships. So where's the middle of that distribution of scores, and how spread out are those scores?